we'll be using a high-speed steel drill drilling into stainless. So for that combination, we want to run 40 surface feet per minute. Now from that, we need an RPM. You take the diameter of the hole you're drilling and put it into the formula with the 40 SFM, and you come out with 600 RPM. So we'll drill at 600. We'll set the 600 here. We'll lower it down and put some drilling fluid on for the hole and drill it. This is a hole saw you'd get from a home store. It's made out of high-speed steel, 2-inch diameter. So it's going to have the same SFM as the drill did because it's high-speed steel and we're drilling into stainless. But the diameter is now up to 2 inches. So the RPM is going to be a lot lower. In this case, the RPM comes out to about 75. This is running the drill press at 75 RPM with the high-speed steel hole saw. Because of the low RPM and the torque required, it's not super happy about this, as you can see. This is a new option. Even at the home stores, you can obtain a carbide tipped hole saw, which can be run roughly 3 times faster than the traditional high-speed steel. In this case, giving us an RPM of 225. The drill press runs much better at a higher RPM like this. We're going to show the complete drilled 2-inch hole in this 304 stainless. Now I'm not going to use oil for the coolant lubricant here. I'm just going to use straight water. For stainless and carbide, the big thing is the heat. You want to keep the heat down, and straight water is going to be your best bet there. It's going to be less messy too. It's not going to smoke like any kind of oil-based lubricant will. So again, just using straight water and lots of it. You might notice that the display RPM has jumped up a little bit, about 270 here, but the sound of the saw is relatively constant. So what you're seeing here is something called a slip factor when you apply torque to the motor, especially at low speeds. So while the drive is asking for more RPM, the actual delivered RPM is roughly the same as we had under idle conditions.